Okay, thank you, Marco. Good afternoon, everyone. As always, I want to know where are you coming from today, and you can use the mark or the arrow on the map and put on the map, and use the drawing toolbar on the upper side of this slide. So on the left side, you can see the weather for today over Portugal. You can see some clouds. As Bruno was saying, that we are, at least in Lisbon, we are with overcast now, maybe with some sun later in the afternoon. So I will talk about the current weather situation, and my colleague Bruno will talk about some past events. Okay, thank you. Let's move on. Mainly West Central Europe. Okay, let's move on. Thank you so much. So this is the meteor alarm information for today. There are some areas of concern, mainly yellow with some orange patches. They are mainly for winds and also some floods and some related snow events. And there is a red warning for a group of little islands in the middle of the Atlantic. So the western islands of Azores have red warnings for winds, and we see later why. So the 9 UTC RGB image with 300 hectopascal height overlaid show on the both sides this area here and this area here. So on the both sides, so deep troughs, and in the middle we have this ridge mainly over southwestern Europe. This also over the northern parts. I will also over here we have some frontal systems, and that are giving some severe weather or some winter weather over these areas. So we have the frontal system over Central Europe is moving southeast. We have another system over southwest of British Isles. It will bring some severe weather later today, and we have this cutoff low at over southeastern Europe, and is moving east. And there were some thunderstorms yesterday over this area. And also in the middle of the Atlantic, we have the storm that is already have a name. It's the storm Justine. And also I want to show you very well the tropical air mass with this green color over the ridge. You can see very well over this area. So the same RGB image, but now with the ECMWF, mean sea level pressure. And again, it's possible to see several lows associated to the upper troughs we saw in the previous slides. So there is this one here, over here, this one also here, and one here. So they are surrounding all the ridge that is in the middle of the image. So the blended TPW from microwave sensors from polar orbit satellites shows here that some humid air mass is moving towards Europe. Nevertheless, the TPW values are not as high. So we are in winter, some values of 30 millimeters, but they are moving along with these waves and lows that are moving over the Atlantic. Also, this 10.8 and 10.8 enhanced is a perfect overview of the systems that can cause some impact in the next hours and, of course, in the next few days. Again, this one over here, we have to monitor this one and also this one. At this point, at 9 ETC, they were really active in these areas. This one here, mainly this one, is moving north or northeast and is going to affect the British Isles in the during the afternoon. So this is the night microphysics image at 6 UTC, and another way to see the quite clear the thick cloudiness within this frontal systems, very thick. Let's change the color. So this one here, also this one here, and of course, we see that this thick cloudiness. But over Iberia and northern Africa, with some areas with low water clouds here, with some patches of cirrus with this dark blue cloudiness, is upper level cloudiness. Now at 9 ETC, I had to split the image because in parts of Europe, almost all Europe was already day, so we cannot use the night microphysics. But areas over the Atlantic, it was still possible. Can you show me where you can find areas with possible fog or low clouds at 9 ETC? Okay. Okay. I was thinking, yeah, it's perfect. Low clouds, of course. The whitish areas are all low clouds. And with a loop, with several images, it was easier to see if they are moving clouds or if they are not moving, so it's easier to say if it is fog or not. But very well, thank you. Okay, I will clear all annotations, and I will now ask you if you can see some areas with snow on the ground. Yes, very well, very well. Perfect. Thank you very well. That's perfect. Okay, let's move on. Okay, now I will talk about a little bit more about Storm Justine. that is over the Atlantic, and that will bring severe wind gusts to Azores later today with the red and orange warning. So Storm Justine is a rapid cyclogenesis, and at 9 UTC was still in a deepening phase. These are some the characteristics of the rapid cyclogenesis, little different from the classical cyclogenesis. Main differences are here. So we have a system with deepening speed, so 24 hectopascal pressure drop in 24 hours. In case of Justine, will drop approximately 23 hectopascal between later in the afternoon yesterday at 18 UTC and today at 18 UTC, so it's still deepening. As a strong warm advection, I will show you, and also dry intrusion, so a clear dry tank, a cloud spiral formation in a later stage, so we cannot see it today, and we also have some rapidly rising colder conveyor belt that forms the cloud head and later the occlusion spiral. So we have to look at the rapid cyclogenesis model with the conveyor belt model that we can see the differences between the classical model. So this is the air mass RGB of Justine, and you can see here some key parameters of rapid cyclogenesis, the conceptual model, and we have here potential vorticity. So we have high values over the dry intrusion area. We also have the winds at 300 hectopascal. Sorry about this mistake. It's not 700 hectopascal. It's 300 hectopascal. So we have the jet streak, and I show you here the jet streak. So we have here the jet streak along the rear edge of the frontal cloud band, and the cloud head within the left exit region of this jet streak. So here. More key parameters. We have the temperature advection. As I said, the maximum of warm advection within the cloud head and the warm front shield. And it's a very strong warm advection, much stronger than the classical model. And also the positive vorticity advection maximum, it is within the area of the cloud head, okay, mainly in this area here. So these are some key parameters, and this cyclogenesis is still on the way and still deepening. So these are some key parameters to monitor. And of course, the water vapor 6.2, it's very good to help monitor rapid cyclogenesis along with the air mass RGB. So we have here very well the dry intrusion. So let's move on. Just a few more slides to see where Justine came from. And there is the wave that later origin Justine just off the east coast of United States on the 26th January at 0 UTC. So here is the wave that later became Justine. So today at 6 UTC, Justine was already here in the middle of the Atlantic, so 2 days later, more or less. And from NOAA analysis, we can see here developing hurricane force. So it's still it's a big it's a windstorm severe and deep low that is going to move towards this region here and is passing near Azores. Azores are here and is passing near Azores, and that's why it's going to bring some severe gusts, wind gusts. And yes, I want to show you also this cloud phase RGB from yesterday at 15 UTC. So you know this is a future RGB that will be available in the new AMTG satellite. The new channel will be the near infrared 2.2. And this channel is very good at discriminating cloud particle size. And as the near infrared 1.6 is very good at discriminating cloud phase, that's why they are used together. So let's focus on this area within the white square. So let's focus on Justine. And we have some examples here. We have two examples with major contribution of the red beam. And this means that we are present with thick water clouds. The yellowish with small droplets, and the purple magenta with large droplets. This area of purple with the blue beam means that we have some thick cloudiness over here. So more information about this you have here. Some limitations, of course, you can only use on only daytime. It's a very good RGB for separation between ice and water clouds. And this RGB, along with others, this RGB is very good to monitor convection. So, last, to show you the extreme forecast index for wind gusts from ECMWF for today. And you can see this area with the high values of extreme forecast index approaching Azores and the western highlands over here. And for tomorrow, we'll have we continue to have some. The Atlantic is very busy with some train, almost a train with some lows and deep lows. So this is associated to Justine, and there is another one that is coming. And also, of course, we have some areas to monitor over Central Europe. And this will have, of course, some impacts over the ocean, and we have the significant wave height for the 30th January. So this is from, will be from Justine, and we have another one, areas of significant wave height, and that are progressing towards Western Europe. And last one is the Justine trajectory from today's ensemble forecast. So maybe here it's more or less clear, then we have some uncertainty over this area. Does Justine go further north or go further south? And we also have a member that goes towards Mediterranean and then towards east, which is quite interesting. So we have some uncertainty around the Gulf of Biscay, but nevertheless will bring some winds for the next hours, 24 hours at least. Okay, that's all for me. Now it's Bruno that will present his events from the past weeks. Thank you.
So, hello, good morning, good afternoon. So I'll start with talking about the storm Filomena, which was named by the IMET at 5th of January, with warnings being issued for strong winds, heavy rain, and snow, with snow being the most hazardous of the event, and expected to hit the inland of the Iberian Peninsula, mainly Spain, with heavy snowfall at low altitudes. Portugal also had some snow in unusual places in the south, but nothing with accumulation that was for a warning. Heavy rain was mainly for the Canary Islands and the southeast of Spain. So here you can see that this low originated on the other side of the Atlantic Ocean, and to reach that, it activated and over warmer waters and hitting first the Canary Islands. So here it's a little bit difficult to see, but Canary Islands are here. We have the British Isles up here, and the Iberian Peninsula over here. Okay, let me clear my notations. So on day 4, we had some some reddish color tones indicating still ongoing cyclogenesis, and we can see also cyclogenesis in other days. Can you point it out? Here the low that was Filomena. Maybe there are some days with that we can see that have more reddish and indicating that ongoing cyclogenesis. I don't know if you can see, but yes. Yes. Also, near the low, we had some. We cleared these. We had some reddish tones indicating that ongoing cyclogenesis, and I think particularly when the low hit the Mediterranean Sea. So here on the last of these days, we have a new activation of the low in that area. Just to explain some the prior weather, we had since Christmas the whole peninsula was under cold temperatures with cold air mass, with most of its area having negative minimum temperatures during this period. You can see here in the day 7 the cold air mass on the north side of this of what would be the warm front, and then during the event we had the warm and moist air advancing over that cold air mass, and almost all the precipitation occurring was in form of snow at the 8th and the 9th of January over Spain. So after the event, we had a week of cold weather also, with a high located northwest of the peninsula, with cold air being advected over Spain, and several records were beaten for minimum temperatures. Here you can see that the snow remained for several days among areas where they are not usual, and I'm perfectly sure that you can see here and point out the snow areas in these RGBs. I use this, yes. So it's a large area inside the Iberian Peninsula, and mainly these slides and next slides will be for distinguish it from the snow between the snow and the fog or low stratus. And that it's easier to do with these various RGBs. So we will use the next slides to detect some snow using these RGBs, not the RGB snow combination, and also detect fog and low stratus, and you'll get an overview of the extent of the area affected by this snow event. So in this first slide, we have the RGB HRV clouds. It comprises two HRV channels and one the infrared 10.8 inverted. So higher signals on this channel mean cool brightness temperatures. But this kind of channel make it impossible to distinguish between the snow and the fog. In the two HRV channels, there is a small difference in signal between fog stratus, as you can see, and the snow. So the solution for this, using this one, and as Angela already has said, we can loop some images to help distinguish the snow from moving clouds, if that's the case, or use other RGBs at the same time. So looking at the RGB for HRV fog, as the previous one, it has two HRV channels, so it's a high resolution visible. And as in the RGB clouds, we can see a small difference in ink signal between the snow and the fog. Pardon, the fog and the snow in these channels. This one has the channel included the near infrared 1.6, and you can see that there's a high contrast between the snow and the fog or low stratus you can see in other places. So the only limitation for these channels that snow can't be seen under high or thick clouds. So, but this channel is also used with the RGB snow. Looking at the natural color RGB and comparing it to the previous RGBs, you can see it lacks some special resolution, although it's not easily seen here. But it lacks the special resolution because it doesn't have the HRV channel in its combination. So instead of having a 1 kilometer resolution, a near 1 kilometer, it has the 2.5 kilometers of these channels that it uses for this combination. It's a similar RGB than the last one, and it also has a good contrast between fog stratus and snow, that it's mainly provided by the near infrared 1.6 and visible channels 0.6 and 0.8 also have that small difference between fog and snow, but it's not the contrast we have with the near infrared 1.6. Looking at RGB microphysics and comparing it with the previous RGBs, we can see that it's not remotely similar to a true color RGB, and as seen before with the 0.8 Vs and the 10.8. And mainly with the last one, we have a poor contrast between fog and snow. But this RGB has this different channel, the infrared 3.9, that is also used on snow RGB. That here only uses the reflected part of the 3.9. So, but this image here we can see here this image represents the infrared 3.9 with both the reflected solar part and the emitted solar part. So we can't have a direct relation between the image and the contribution of the signal. The signal we can see here on these boxes. Despite of these, we know that the solar part of this channel has a smaller contribution for snow-covered land than for low clouds, so creating a good contrast, and that's also why it's used on the snow RGB. In this case, you can mainly use it to detect fog and stratus. You can see it really well here in these places. Now looking at all RGBs, the RGBs we have seen are only available during the day, also as the snow RGB, which uses the visible 0.8 and the infrared 2.9 with the solar part. But in some very particular circumstances, it's possible to detect snow during the night with the night microphysics RGB. Here you can see it a little bit of that possibility, but the temperature has to be very low, and the snow has to cover all the vegetation for this to occur. And here, comparing it with the daytime RGBs, you can see this similar area. So, looking at some photos, you can see some photos from Madrid, where the snow accumulated near 50 centimeters, and making this event the most hazardous of the last 50 years, the most hazardous of snow events in the last 50 years. Now, just a quick look at Christoph and Gaetan. And these are also two named storms. Well, the Gaetan was named was named on the 18th of January from IPMA for expecting prediction of strong winds and also high waves in Portugal, also in Spain, and we had wind gusts that reach 110 kilometers an hour on lowlands and 150 kilometers an hour in highlands. Christoph was named by the Met Office also on the 18th, and mainly for floods, but also for snow and wind affecting the British Isles. Here we can see the images with these two storms very close, and even they were caught by the same passage of the ASCAT V, so it's a very good image where you can see both of them, and here we also have some dry intrusion, and you can see that Gaetan was in a cyclogenesis mode. And the next slide, I'll just put it here just to see that we have the water vapor 6.2 and infrared 10.8. They're mainly used they're also used for the product of convective rainfall rate. We can see here, so we had near, especially in Gaetan, we had convection, and you can see the dry intrusion at the water vapor 6.2 here near Gaetan. Christoph was more of a persistence of precipitation over the British Isles, and I use here also the 7.3, which is for lower altitude than 6.2, and you can see here the convective rainfall rate and the top of the clouds, very cool here, and here associated with Gaetan and Christoph. Just a quick look of those two, and also some photos from the United Kingdom, and you can see the floods eating various places in there. So thank you very much. There will be a next weather briefing on February, and Marco will talk about it. And I put here a resume of the Atlantic named storms from the southwestern group and the west group. And we are already in 6 storms in this January. Thank you.